Intelligent design and DNA. Scholars can't explain it all away. Get ready to be awed by the handiwork of God. Tune into Real Science Radio. Turn up the Real Science Radio. Keeping it real.
So we've covered our evidence against the Big Bang. That's like the red meat for Big Bang opponents, because when proponents defend the Big Bang, they don't tend to bring up the discoveries we just looked at. Now in part 2, the Big Bang predictions, we meet the proponents on their own turf, because unlike the list we just saw, these next 3 items are exactly what Big Bang proponents, like NASA, say confirm their theory, the Big Bang predictions. So here are the primary 3 that they offer. CMB, that's the cosmic microwave background prediction. The elements, the amounts of hydrogen, helium, lithium, and so on in the universe. And then the expansion, that the Big Bang theory predicted an expanding universe. But you guys are creationist exaggerators, right? You're just bringing up these 3 because you think you can knock them down like a straw dummy. But even if you could, which you can't, there's probably other Big Bang proofs way more important than these. Well, you can see here from NASA's website, where they tried to convince the public that the Big Bang is true, that they show 3 tests of the Big Bang theory. We'll look at a couple excerpts from this page and see that they claim, as they list there, that it is the cosmic waves, the elements, and the expansion of the universe that confirm the Big Bang theory. Along with Lawrence Krauss and an army of largely secular astronomers, they claim that the Big Bang predicted these 3 things, and since these predictions have been confirmed, therefore we should all trust the Big Bang theory. The problem is, this canonical story is not true. So let's watch the Big Bang prediction story unravel, starting with this video made by the European Space Agency.
ESA has released a new map showing the first light of the universe that challenges some of the fundamental principles of the Big Bang theory. This latest cosmic microwave background map from Planck, ESA's mission to investigate the origins of the universe, questions some of the concepts behind the basic theory of the expansion of the universe, commonly known as inflationary theory.
We see these strange patterns that are not expected, in inflationary theory, the simplest inflationary theories. It may be that that we've been fooled, that inflation didn't happen.
In constant rotation, Planck scans the entire sky at millimeter and sub-millimeter wavelengths. Visible light telescopes see little more than the tapestry of galaxies around us, but by making measurements at wavelengths between the infrared and radio, Planck is able to work back in time and show us the history of the universe from the first light ever produced. These fossil radiations resulting from the Big Bang are called the cosmic microwave background. What's surprising in Planck's latest findings, and is inconsistent with pervading theories, is the presence of unexpected large-scale anomalies in the sky, including a large cold region, stronger fluctuations in one half of the sky than the other, and less light signal than expected across the entire sky.
When you look only at the large features on this map, you find that our best fitting model, our best theory, has a problem fitting the data.
Planck, launched in 2009 by Ariane 5, is the 3rd mission to study the cosmic microwave background to date. While these unusual features in the sky were hinted at in the 2 previous US missions, COBE and WMAP, Planck's ability to measure the tiniest of fluctuations in the cosmic microwave background has made these so-called anomalies impossible to ignore.
Because of these features that we're finding in the sky, people really are in a situation now where they cannot ignore them anymore. They have been hints of these things in the past, and they have been able to ignore them, but not anymore, because we've established them as facts.
It's this very accuracy that may now make it necessary for scientists to rethink some of the underlying theories of how the universe began and how it's evolving.
In layman's terms, there are big problems with the Big Bang, CMB, and even in that video, they barely touched on them. First, there's something that physicists have been calling the axis of evil. They call it evil because it looks like the universe is lined up with the Earth. And if that's true, that's evidence for the creator of mankind. Then there's the missing shadow of the microwave background, for the CMB is believed to be coming to us from every point throughout the universe. And if so, the CMB should be dimmer than behind nearby galaxy clusters, but it's not. So there's the missing shadow of the Big Bang. And also the very cold 2.7 degrees Kelvin background radiation, that was known before it became a prediction of the Big Bang. As with the elements and the expansion, it was known long before it supposedly was predicted. So first, the axis of evil. Here's an illustration of it. Those two spheres are maps of the CMB, ostensibly maps of the universe, and as that illustration of the solar system indicates, these maps suggest to astrophysicists that the universe appears to be lined up with the Earth's orbit around the sun. To someone who knows Jesus Christ and his love for us as our creator, that's not surprising. Here's an article from Europe's leading science magazine, New Scientist. I'll make that headline larger for you, referring to this by its popular name, the axis of evil. It's the magnitude of how shocking this is to atheists. Materialists realize how tiny the Earth's orbit is, compared even to the nearest stars, let alone all the billions of galaxies in the universe. So first, the Big Bang Theory denies that there would be hemispheres, differences in the northern and southern hemispheres of the universe. And also, it's inconceivable to them that the Earth's orbit would define that plane, but it does. It's so unthinkable. It'd be like finding a book that foretold the coming of Jesus Christ. Oh wait, there is such a book. It's in their hotel rooms, and the whole history of the Earth aligns with its first and last pages. But to learn more about this axis of evil, at our website, rsr.org/axis, you can get all the scientific papers published in the world's leading journals and links to the science press discussing this. For example, here's Lawrence Krauss on the axis of evil. Quote, "But when you look at the CMB map, you also see that the structure that is observed is, in fact, in a weird way correlated with the plane of the Earth around the sun. That's crazy. We're looking out at the whole universe. There's no way there should be a correlation of structure with our motion of the Earth around the sun, the plane of the Earth around the sun, the ecliptic." And of course, you can get the source and a link to that quote from Lawrence Krauss at our website, realscienceradio.com, or the shortcut, just rsr.org/axis of evil. This frank quote continues, "That would say we are truly the center of the universe. The new results are either telling us that all of science is wrong and we're the center of the universe, or maybe the data is simply incorrect, or maybe there's something wrong with our theories." Yes, maybe there is something wrong with them. I'll show you another map of the CMB, this one looking at the data in what is called the K-band at 23 gigahertz. When they launched the Planck satellite, this third-generation technology to refine this data, they were hoping that the axis of evil would go away, that it was just some error in their data collection, but instead it just keeps getting more evil. These atheistic science magazines refer to this feature of the CMB as the axis of evil because, as with abortion and socialism, they call evil good and good evil. And they think the map of the CMB looks like God is pointing to the Earth, saying that we are special in his eyes. An atheist sees evidence like that as evil, an axis of evil. And before we get to the missing shadow of the CMB, remember this page, Internet Search Rankings? If a curious person Googles evidence against the Big Bang, they just may click on the top-ranked web page and see our list of evidence, and hopefully learn from our message to fear the Lord and to love Him. And by the way, our regular listeners know this, but rsr.org equals kgov.com, the home of Bob Enyart Live, and it also equals realscienceradio.com, just FYI. But remember, that search term is more of a creationist or a critic's search term. What if this were a student or a science journalist or a Methodist minister who believes in the Big Bang, and they've heard from NASA and everywhere that the predictions of the Big Bang confirm the theory? Then they just might Google Big Bang predictions. With that search, Google ranks Real Science Radio #1 out of 1 million related web pages. And notice, this is not a creationist search term. It's a secular term. So we're reaching people, and you could help. If you link to our webpage, rsr.org/bbp, in a comment under an astronomy article or in a blog or wherever, that will help us stay at #1. For the vast majority of people who search for a term, they click first on the top-ranked result. And you could also help when you search for one of our articles and you click on our kgov.com webpage instead of on our competitors page, like say Wikipedia. That really helps our rankings. Does high Google ranking mean that the information is true? Well, of course not. But it often means that that web page reliably covers the material from the point of view that it represents. Now, the missing shadow of the Big Bang's CMB. If there's no shadow, there's something very wrong, no? Well, this from the Astrophysical Journal on a vital test of the Big Bang. Yet, quote, taken at face value, one may even hold the opinion that there is, in fact, no strong evidence, that is, for the Big Bang shadow, from behind 31 nearby galaxy clusters. If there's no shadow, there's something very wrong, no? The claim is that photons from the Big Bang, not from the bang itself, but an afterglow. Photons that were in existence 380,000 years after the Big Bang are now flooding the universe almost exactly evenly from everywhere. And even though they're coming from every direction, this is the claim, even so, we should still be able to see a shadow if they're blocked coming from any particular direction. For example, a nearby galaxy cluster should cast a shadow. Even actors in a well-lit Broadway play still cast a shadow. Even if he's a rich man with one staircase going up and another coming down just for show. Notice those shadows. We've illustrated them as being cast from behind not just galaxies, but more than that, from behind galaxy clusters, which are gravitationally bound groupings of galaxies. Here's a popular science media outlet, Science Daily. Their headline reads, Big Bang Afterglow Fails Intergalactic Shadow Test. That's not an example of all evidence supporting the Big Bang. And along with all the other problems of the CMB, this one is perhaps the biggest for the Big Bang, because it would mean that the CMB itself is not coming from all over the universe, as in a Big Bang. That's not an example of all evidence supporting the Big Bang. And along with all the other problems of the CMB, this one is perhaps the biggest for the Big Bang, because it would mean that the CMB itself is not coming from all over the universe, as in a Big Bang, but all that static is somehow just a local phenomenon, maybe only within the Milky Way. She better watch out for that guy. There's something wrong with him. If you don't have a shadow, well, as Dr. Richard Liu put it, these shadows are a well-known thing that has been predicted for years. If you see a shadow, it means the radiation comes from behind the cluster. If you don't see a shadow, then you have something of a problem. If there's no CMB shadow, then that means that this scientific observation has destroyed, in yet another way, one of the biggest claims of the CMB as confirmation of the theory. Now, the prediction part. Was it even a prediction of the Big Bang? Back in the 1930s, George Lemaitre, father of the Big Bang, interpreted a signal. It wasn't the CMB, but they had data that they interpreted as the echo of the Big Bang, until they found out that it wasn't. And then in the early 1960s, something similar happened regarding the so-called prediction of the CMB. I've underlined 3 things in this quote for you to remember, because we're going to find out that these 3 things were already known about the microwave radiation. From NASA, the important prediction that the cosmic microwave background, CMB, exists and has a black body spectrum with a temperature of about 5 degrees above absolute zero was a byproduct of this work. So there was a prediction of 5 degrees, about double of the much closer temperature that had actually been measured and published years earlier. The 5-degree temperature prediction, that was the work of Alpher and Herman working under George Gamow. A Nobel Prize was given to 2 men, Robert Wilson and his associate, for their so-called discovery of the CMB. But I think you'll be able to see that Robert Wilson was used. He spent years wrestling with whether they even deserved to win a prize. I think he was used to promote the Big Bang story. We had scientists predicting that there would be a static signal out there in space, and it would have a very low temperature, maybe only 5 degrees Kelvin, and it would have a certain type of radiation pattern called the black body spectrum. Here's a video of historic footage of Wilson and Arno Penzias. Working in New Jersey in 1964, they were trying to figure out for AT&T what the static was in their satellite receiver. An old TV antenna gets some of its static from the CMB. These clips are from a PBS Nova program on the Big Bang, and in a moment we'll hear from Robert Wilson himself. But first, Princeton astrophysicist David Spergel will tell us that now, finally, with Penzias and Wilson's discovery, we had actual data to prove the Big Bang. The problem is, they already had this kind of data for decades.
Penzias and Wilson's discovery of the microwave background is what made cosmology a science. All of a sudden you had data, and you really tested a theory. You had a theory that said the universe started with this hot Big Bang, and what Penzias and Wilson saw was this leftover heat from the Big Bang.
When the Nobel Prize was announced, I think probably one of the first things I thought about was, do I really deserve this? And should my name be on the same list with Einstein? Which just seemed completely wrong. Over the years, I guess, I've come to understand that the Nobel Prize is given for discovering something, not for being the smartest person around. So while there are much smarter people around, we did something significant, and I feel comfortable with it now.
If you noticed, Wilson gave 2 reasons for his hesitancy about winning the Nobel Prize. First, he wasn't as smart as Einstein. And then second, I think his real concern, that they didn't deserve the prize. It just seemed completely wrong. But over the years, he came to terms with it. So when Robert Wilson gave his Nobel lecture, let's see what he said. The first confirmation of the microwave cosmic background that we knew of came from a totally different, indirect measurement. This measurement had, in fact, been made 30 years earlier by Adams and Dunham near the peak of a 3K black body spectrum. 30 years earlier, that's 30 years before Penzias and Wilson measured the CMB. So this prize winner is saying that discoveries at Mount Wilson Observatory beginning back in 1937 had already found the CMB. So on the occasion of receiving the world's most prestigious physics award, a Nobel Prize winner acknowledges that his discovery was already known, which discovery, though, is the only reason, ostensibly, that he's being honored and given hundreds of thousands of dollars, because he discovered something. But this was before the age of the internet, and Walter Cronkite wouldn't know, and the New York Times wouldn't know, and not even would the science reporters know that this discovery had already been made. I think Wilson was used. We know he was uncomfortable about the whole thing, and he probably acknowledged this in his lecture in part to ease his own conscience. So the Big Bang prediction of the CMB by George Gamow and his guys over at Princeton was more of a post-diction. It would be like me predicting that there are deep trenches in the floor of the Pacific Ocean. Robert Wilson seems like a humble man who was used to promote the Big Bang Theory. After 30 years, that idea was not helping to make discoveries. It was languishing, and it had not become a monopoly among cosmologists. But give it the Nobel Prize, which is what happened. Wilson was a stand-in for the Big Bang. Penzias and Wilson were the excuse to kickstart a stalled cosmology, and it worked. And Wilson, the accidental laureate, was left uneasy about the mania swirling about him. Remember Bill Nye the Science Guy? Well, now that we know the rest of the CMB story, and before we move on, let's look at the way this media favorite misrepresents science to the public.
Arno Penzias and Robert Wilson had found this cosmic background sound that was predicted by astronomers. Astronomers running the numbers, doing math, predicted that in the cosmos would be left over this echo, this energy from the Big Bang that would be detectable. And they detected it. We built the Cosmic Observatory for Background Emissions, the COBE spacecraft, and it matched exactly the astronomers' predictions. You got to respect that. It's a wonderful thing.
I'm thankful that millions watched that debate between Bill Nye and Ken Ham at the Creation Museum. Even though Nye, the atheist supporter of the Big Bang, misrepresented the science throughout, like he did with the CMB, still, it gave Fred Williams and me the opportunity to analyze that event on Real Science Radio, and more importantly, Ken Ham was able to tell millions, literally, about God as our creator. So that's the rest of the story of the CMB. Its axis of evil, its missing shadow, and its fame as a prediction after the fact. Now the second confirmation, that the Big Bang Theory predicted what percentage of the universe would be made up of the light elements, hydrogen and helium, and a bit of lithium. And there it is again on that NASA Big Bang webpage. The light elements were another central test of the theory's predictions. We're going to look with a bit more of a critical eye than is customary at the Big Bang Theory's actual track record on predicting primordial abundances of the light elements. You'll have to keep your eye on the blue part of the pie. It starts out as most of the pie, then shrinks to become just a slice. It's the blue part that's what the Big Bang advocates brag that they got right. Hydrogen and helium, they make up 98% of the elements in the universe. All the other elements make up about 2%. The missing antimatter, remember that? 100% of what's there should be doubled in antimatter. And then there's dark matter, claimed to be required to make a Big Bang universe function. That's missing. That's 23%. Would there be anti-dark matter? And then there's dark energy, also claimed to be required to make a Big Bang universe function. That's missing, and that's 73%. Then there's the missing baryonic matter. If the Big Bang were true, then of the abundance of light elements that we see in the universe, the hydrogen and helium, fully half again of all that is, well, missing. It's called baryonic matter because it's made of baryons, which are subatomic particles made up of 3 quarks, like protons and neutrons. On our website at rsr.org/BBP_baryons, you can learn about this from 2 physicists, Dr. Jake Hebert with the Institute for Creation Research and Lawrence Krauss, both explaining that there's another 100% of all the hydrogen and helium that we have that's missing if the Big Bang were true. So we can't give the theory credit for predicting stuff that's never been found. And those missing monopoles on our pie chart, imagine a magnet with positive and negative poles, and then erase one of the poles, and you'd be left with a monopole. The Big Bang predicts a great density of monopoles, and you can learn about that at our website. So the part of everything in the universe that we're saying that the Big Bang Theory was able to predict was this, right here, that tiny part. And would you be surprised if there wasn't still even more to the story? Because they really didn't just predict that part out of the clear blue either, or out of their theory. They had, well, help. And there was a lot of fudging going on. This quote is from that same NASA webpage on the Big Bang that we've been referring to. Quote, "We generally expect about 24% of the ordinary matter in the universe to be helium produced in the Big Bang. This is in very good agreement with observations and is another major triumph for the Big Bang Theory." Major triumph? Well, okay, for that 1% of the stuff of the universe that they say they got their theory right. But even at that, they got quite a bit of help. The early Big Bang Theory prediction of elements was way off and mostly not talked about. Then they redid everything with a lot of help. Not quite as bad as a weatherman predicting that in the evening we're expecting darkness and then tomorrow things should lighten up again. Not quite that bad, but they weren't predicting out of the blue, but right into the middle of an enormous amount of research, studies, databases, and estimates providing all kinds of information to constrain their prediction about hydrogen and helium. Now this quote from 1990, that's a while ago, but not in the dark ages. In 1990, the most prestigious science journal in the world, the British peer-reviewed Nature, published this, quote, "It is commonly supposed that the so-called primordial abundances of hydrogen and helium provide strong evidence for Big Bang cosmology, but a particular value for the baryon to photon ratio needs to be assumed ad hoc to obtain the required abundances." They were the required abundances because an army of astronomers had been working all along to determine what the elements were that the stars were burning. By the way, the authors of this paper in Nature, they were known critics of the Big Bang, and they were also famous and accomplished astronomers and physicists, including one who happens to be the father of the theory of stellar nucleosynthesis. In our pie chart, we included the missing 50% of the hydrogen and helium in the universe. But there are other problems with the elements that a Big Bang would create. There's the helium problem, described a while ago by a respected scientist in his Modern Cosmology, published by Cambridge University Press, of stars that have 100-fold too little helium if they were produced out of the gas of the Big Bang. And there are the widely discussed and researched problems between the predictions of the Big Bang and the apparent amount of lithium in the universe. So there's the lithium problem. Then there's the more specific lithium-6 problem. And there's a lithium-7 problem. Then the next two lightest elements, there's the beryllium problem and the boron problem. Again, you can learn about these problems at rsr.org/Big Bang Predictions or /BBP for short. So here with physics essays, we've moved up to 1997. And again, in a respected peer-reviewed journal, quote, "The study of historical data shows that over the years, predictions of the ratio of helium to hydrogen in a Big Bang universe had been repeatedly adjusted to agree with the latest available estimates of that ratio as observed in the real universe. The estimated ratio is dependent on a ratio of baryons to photons, the baryon number, that has been arbitrarily adjusted to agree with the currently established helium to hydrogen ratio. These appear to have not been predictions, but merely adjustments of the theory, retrodictions, to accommodate current data." So, this is what they're claiming bragging rights over? repeated adjustments to their predictions so that they could match the millions of actual measurements of the heavens that had been published as they were doing the tweaking of their so-called predictions. And again, it's only 1% anyway. Remember Occupy Wall Street? No? Yeah, not too many people do. Well, anyway, they were the 99%, they said. NASA is acting like the Occupy Wall Street of astronomy. They claim that they're the 99%, or that their side predicted almost 99% of everything by their theory, but they didn't. So at least now we're up to 2004. And this isn't only written by an author or some co-authors. This open letter, published in New Scientist, perhaps Europe's most popular science magazine, this has been signed by hundreds of scientists and researchers, including many from some of the world's most prestigious institutions, and I'll show you them. They wrote, quote, "The Big Bang Theory can boast of no quantitative predictions that have subsequently been validated by observation. The successes claimed by the theory supporters consist of its ability to retrospectively fit observations with a steadily increasing array of adjustable parameters." The authors include scientists at these institutions: Max Planck Institute for Astrophysics, Sheffield University, George Mason University, Jet Propulsion Laboratory, and that's run by Caltech, Cambridge University, Penn State, Lawrenceville Plasma Physics, Cal State Fullerton, University of Virginia, European Southern Observatory, and scores of other prestigious institutions. So are they all creationist exaggerators? Is this just Real Science Radio claiming that NASA is fudging the numbers to pad next year's budget? Because when they promote a non-biblical worldview, whether global warming, life evolving on Mars, or an anti-Genesis, anti-Christ origin of the world without God, then they are in their sweet spot for cultural approval. If they want to double their budget for next year, all they'd have to do is plan a same-sex wedding in space. That would do it, because this is all about political correctness. These hundreds of scientists, here's how their full-page letter begins. The Big Bang today relies on a growing number of hypothetical entities, things that we have never observed: inflation, dark matter, and dark energy, we could add some today, are the most prominent examples. Without them, there would be a fatal contradiction between the observations made by astronomers and the predictions of the Big Bang Theory. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. It would, at the least, raise serious questions about the validity of the underlying theory. But the Big Bang Theory can't survive without these fudge factors. Now let's have a moment of silence as I scroll through these signers for you. So we've covered the CMB and the claim that the Big Bang Theory accurately predicted the abundances of the light elements. Now for the expansion. That same NASA website says, as is widely claimed, that the expansion of the universe is both confirmed and therefore, since expansion is a prediction of the Big Bang Theory, it also confirms the theory itself. In this last section of our Part 2 on the Big Bang predictions, now we'll look at the claim on NASA's website that the Big Bang Theory predicted that the universe would be expanding. That's not true. But to help the theory's promoters tell that story, over the years, they've consistently predated when the Big Bang Theory was proposed, and they post-date the claims that the universe is expanding. George Lemaitre, in 1931, sent a letter to the journal Nature and proposed his Big Bang Theory. But it is frequently claimed that the theory was proposed back in the 1920s, or even specifically in 1927, which is simply not true. And conversely, the theory's promoters post-date the claim that the universe is expanding, attributing it to Hubble, when a lot on that topic was published prior to Edwin Hubble. So let's look at this. So we're back at NASA's website, and we'll read here what they say about expansion. Then we'll look at some of the historical facts about the Big Bang, and then return to this quote, and we'll see that they are overselling their claim. Quote, "The Big Bang model was a natural outcome of Einstein's general relativity. In 1929, Edwin Hubble announced that his observations of galaxies outside our own Milky Way showed that they were systematically moving away. The universe was expanding after all, just as general relativity originally predicted. In other words, the Hubble law is just what one would expect from a homogeneous, expanding universe as predicted by the Big Bang theory." So, the expanding universe was predicted by the Big Bang? Wow, what a claim. We'll see. So when was the Big Bang theory first proposed? In 1931. To prepare for this section of the seminar, I've read from the 1920s and 30s a dozen journal papers and this letter from George Lemaitre. As is acknowledged by many, but shockingly not nearly by everyone, the Big Bang theory was first proposed right here, in this letter to the journal Nature, published on May 9th, 1931. Yet countless seemingly reliable sources, like National Geographic, wrongly date the origin of the Big Bang theory. From a long-standing National Geographic article, and one of their main ones on the Big Bang, quote, "A Belgian priest named George Lemaitre first suggested the Big Bang theory in the 1920s. Wow. As you will see, this is not just an outlier, a fluke mistake. No, there are scores of seemingly reliable sources for science news that want to stretch. They stretch the proposal of the Big Bang theory back into the 1920s. And they got away with it for a long time. But the internet and the high Google rankings for creation websites like Real Science Radio is making it harder for them to continue this misrepresentation. And it's not a conspiracy that each author has bought into. Rather, it's convenient storytelling. It's the canonical story of the Big Bang, that the Big Bang theory predicted the expansion of the universe. So to make that story stick, you have to predate the Big Bang and postdate the expansion. And that is what is done widely. CERN is the world's most prestigious laboratory for particle physics, the European Organization for Nuclear Research. This is their Large Hadron Collider, the world's most powerful particle accelerator. It uses superconducting magnets to accelerate particles to nearly the speed of light inside this tube in a circle for 17 miles, making more than 11,000 trips in less than a second. They do all of this, why? Mostly to see what would have happened in the moments after the Big Bang. So you'd think that they would be experts on the Big Bang. But CERN put out an article that included a timeline of the major developments in physics. From that article, Big Bang Theory, 1927. By the way, the New York Times, without correction, ran the same piece. So that's National Geographic and CERN and the New York Times too. But that's only 3 sources. Then there's the American Association of Physics Timeline of Discoveries and the DK Illustrated Reference Book Body Science. By the way, DK is the Penguin Random House International Publishers imprint for adults and kids. And various university texts and encyclopedias and public school curricula with the Big Bang at 1927. It's all wrong. But that's just the beginning of the predating of the Big Bang. I ran out of time collecting them. Here's a screenshot from our Big Bang Predictions article with links to the sources. Science authorities, publishers, physics groups, universities, prestigious timelines, encyclopedias, popular blogs, public school curricula. In each of those etceteras are links to more examples. Near our studio, for example, at the Rocky Mountain PBS television affiliate, and so on. with each of those et ceteras linking to different sources predating the Big Bang. And countless other articles omit any date whatsoever, even when it's the kind of article that would naturally include the theory's date, except that the author noticed that it doesn't fit well into the canonical telling of the Big Bang theory predicting the expansion of the universe. So the date is either wrong or it's left out, and sometimes presented ambiguously, as Nova in the History Channel do so well. So I think I've made my case for the predating of the Big Bang theory. Now let's look at the post-dating of the discovery of the expansion of the universe. This will help with the Big Bang, since NASA and so many, they say that the Big Bang predicted the expansion. So if you nudge the theory back from the 1930s into the 1920s, and then you nudge the declaration forward of the expansion of the universe, then the canonical story has a better chance of convincing people. And to show this point, we creationists have a lot of help, because a number of secular authors are getting tired of the historical revisionism on the expansion of the universe. And it all has to do with a man named Edwin Hubble. Remember this from NASA's webpage? In 1929, Edwin Hubble announced that his observations of galaxies outside of our own Milky Way showed that they were systematically moving away. The universe was expanding. The Hubble law is just what one would expect for a homogeneous expanding universe as predicted by the Big Bang theory. Wow, NASA makes it sound like the Big Bang theory predated Hubble's discovery, which is rather convenient because it wasn't even Hubble's discovery. The discovery came a few years earlier. This 2011 article from the prestigious publication Physics Today states bluntly, it is still widely held that in 1929, Edwin Hubble discovered the expanding universe. This is incorrect. They write emphatically that such a claim is incorrect. Lemaitre published a couple years before Hubble that the universe was expanding, consistent with even earlier published papers. But as Physics Today points out, many sources misattribute to Hubble, and therefore, by the way, post-date the expansion. For example, here's a screenshot from our Big Bang predictions page. These folks ignore that Physics Today article's correction. The popular website space.com says Hubble discovered the universe was expanding. That's just terrible. Cambridge University, Carnegie Institute for Science, Bill Nye, the science guy, says Hubble discovered that the stars are moving apart. He said that repeatedly in that debate with Ken Ham, the creationist. He made a mistake. He meant the galaxies. The history blog, phys.org, Hubble discovered. No, Denver's public broadcasting station, Hubble discovered that galaxies were moving away. The Sloan Digital Sky Survey, of all sources, considered to be so reliable. Hubble discovered that the universe was expanding. And please send your favorite example to me, bob@rsr.org. Each of these are links, of course. And just this month, the History Channel special, The Universe, included this clip.
He single-handedly grew the universe from a quaint one-galaxy town to a potentially billion-galaxy metropolis. But Hubble went one further.
He also measured the behavior of those galaxies, and in 1929, he came to the conclusion that most galaxies are moving away from us. Not just there are lots of them, but they're actually moving away from the Milky Way, and in fact, they're moving away from each other.
In other words, the universe is expanding.
Now we'll correct the record and get right the actual history of the idea that the universe may be expanding. A Different Approach. That's a cosmology text that I've enjoyed reading, written by astronomers who themselves played a key role in the modern history of cosmology. And they were associates with many of the major players, and they set the record straight. Princeton's cosmologist James Peebles. These next are histories of recent astronomy which give an accurate chronology. The day we found the universe, discovering the expanding universe. And now we'll look at the actual timeline for ourselves. In 1912, Vesto Slipher, his paper on the redshift radial velocity of the Andromeda Nebula. In 1917, Willem de Sitter, redshift of very distant stars or nebulae show a spurious radial velocity. In 1918, Carl Wirtz, spiral nebulae are drifting apart by 656 kilometers per second. And then in 1922, Alexander Friedmann, unlike Einstein and Newton, who struggled to explain why the universe doesn't gravitationally implode, Friedmann interpreted general relativity to indicate an expanding universe. Of course, as God created the universe, He is the one who finely tuned its parameters so that it wouldn't implode or explode, unless, of course, mankind rebelled, so that now, as the Apostle Peter wrote, that the heavens shall pass away with a great noise, and the elements shall melt with fervent heat. The earth also shall be burned up. There's that. In 1927, George Lemaitre, he wrote of an expanding universe seen by the redshift of the extragalactic nebula. Now, Lemaitre suggests that expansion began after a period of time in which the universe was static. Sir Arthur Eddington said that its radius, the universe, its radius was 1 billion light years before it began expanding. In 1929, Edwin Hubble, he published a paper on the relationship between distance and radial velocity among extragalactic nebulae. Notice he wasn't the first. His paper included the Hubble law as was published by Lemaitre in 1927. In 1931, Arthur Eddington, he mentioned in passing Lemaitre and belief in an expanding universe, and then Eddington was musing for a few pages on entropy and time, and then states, philosophically, the notion of a beginning of the present order of nature is repugnant to me. So Lemaitre seized on that quote in his brief letter published 2 months later. 1931, also, George Lemaitre, the journal Nature, published his letter proposing the Big Bang. That's the accurate history. So post-dating the discovery of the expansion and predating the Big Bang theory helps with the canonical storytelling, and it wrongly attributes the Hubble law. Not everything we know about Edwin Hubble is admirable. In 1929, Hubble never mentioned the source of his data, astronomer Slipher. Hubble asked J.H. Reynolds to not publish data which Hubble later published without referencing Reynolds. Hubble wrote to De Sitter in 1930, I consider the velocity-distance relation, that is what's called Hubble's law, its formulation, testing, and confirmation as a Mount Wilson, that is, as a Hubble contribution, and I am deeply concerned in its recognition as such. That was pretty much rotten. The astronomy establishment has psychoanalyzed Lemaitre, and they claim he was humble and he didn't desire credit for his original discovery. But he used attention-getting techniques, like using the name of a contemporary famous astronomer as the first words in his opening sentence to start his papers, like Arthur Eddington says. When you do that, you draw attention to yourself. And later, when he wasn't getting the credit, Lemaitre himself tried to correct that in a published paper and pointed out that the title of my paper leaves no doubt about my intentions. Today, defending Hubble, the astronomy establishment claims Lemaitre was humble and that he didn't want the credit. But later, he himself wrote that he did. The smoking gun in all of this was when the Royal Astronomical Society invited Lemaitre to translate for publication paragraphs 1 to 72 of his 1927 paper. Paragraph 73 contains his discovery of the Hubble law. That invitation was a handwritten note. Let's take a look at that. This is the actual invitation from 1930 mailed to Lemaitre from the Royal Astronomical Society. That was the establishment back then. And right there on the screen, that's paragraphs 1 to 72. NASA says that the Big Bang Theory predicted expansion, Now we know that isn't true. Even the most hard-hearted atheist would have to agree that their claim would mislead the general public. So now we come back to this quote from NASA on expansion. The Big Bang model was a natural outcome of Einstein's general relativity. That's a bit misleading. It wasn't until a year after he published General Relativity that Einstein added a constant to support his own view that the universe had existed eternally in a static state. That constant, the cosmological constant, it can be arbitrarily valued as either positive, zero, or negative to obtain a repulsive or static or an attractive force that would tend toward an expanding, a static, or a contracting universe. So actually, an expanding universe is just an arbitrary interpretation of general relativity. When Einstein introduced his theory, it was said that it must imply either a contracting or an expanding universe because it couldn't imply a stable or static universe because then these forces would have to be fine-tuned, exactly balanced to an extraordinary degree. But fast forward to 21st century physics, and virtually the entire world of cosmology and of physics acknowledges an extraordinary fine-tuning of the universe. So general relativity does not imply an expanding universe. NASA goes on to say, however, in 1917, the idea that the universe was expanding was thought to be absurd. So Einstein invented the cosmological constant as a term in his general relativity theory that allowed for a static universe. In 1929, Edwin Hubble announced that his observations of galaxies outside our own Milky Way showed that they were systematically moving away. The universe was expanding after all, just as general relativity originally predicted. Wow, in 1929, moving away? Statements like that reinforce the widely held falsehood that Hubble discovered expansion. And then that expansion was predicted by general relativity? I mean, that's flat out misinformation. Einstein himself interpreted general relativity to refer to a non-expanding universe. Notice how flexible this kind of cosmology is? The success of the Big Bang lies in its ability to simply conform to whatever the latest data or cosmological fad requires. NASA goes on to say, in other words, the Hubble law is just what one would expect for a homogeneous expanding universe, as predicted by the Big Bang theory. Isn't that funny? The theory predicted this years before the theory was proposed? That's called revisionism, misrepresenting history in order to sell something. Cambridge University in the United Kingdom, where Isaac Newton chaired the mathematics department. The math department today looks rather modern. Let's look at a Big Bang presentation from their website. Notice this is from the Department of Applied Mathematics and Theoretical Physics. As we scroll down here, you'll see familiar items: expansion, background radiation, light elements. So this article points out 4 key successes, they call them, of the predictive ability of the Big Bang. They claim these observations are in remarkable agreement with what the theory would predict and that they give us considerable confidence in the model. Even though these claims have been falsified, probably for decades to come, textbooks will be misrepresenting this science to our kids. Formation of galaxies and large-scale structure, that's all evidence against the Big Bang, as we saw from those discoveries in part 1 of this presentation. So we've seen that the theory hardly predicted anything of the matter that cosmologists claim we have in the universe. And we've seen that the CMB, the background radiation, had been measured decades before the renewed attention on it as evidence for the Big Bang. And that the Big Bang theory certainly did not predict the expansion of the universe. So if its predictions were used as a test, then the standard model has failed. Next is part 3 with the big evidence for our Creator God. Thank you.